You're here because you want to master salt preparation with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. So for salt preparation, a very key concept that you have to know is to remember your solubility table. Alright? If you don't know your solubility table, in other words, you don't know if the salt you're preparing is soluble or not, you wouldn't know what method that you have to use to do salt preparation. So how do I remember my solubility table? Well, it kind of goes in rules, right? So rule number 1 is all your group 1 and your ammonium salts, that means if the salt has a group 1 cation or ammonium cation, it's definitely soluble. Next, your nitrates. Okay, any salt with the nitrate anion is definitely soluble. Then rule number 3, right? All your chlorides and bromides, these are all soluble, except if these chlorides and bromides, right, basically these halogens, are paired up with any cation on the right, which is they're paired up with silver or lead. So for example, your silver chloride, your silver bromide, your lead 2 chloride, your lead 2 bromide, right? All these, right? These are all insoluble. Now, your sulfates, right? Anything with a sulfate anion is also generally soluble, except if it's paired with a lead 2 plus ion, barium 2 plus ion, or the calcium 2 plus ion. So for example, right, our calcium sulfate is generally insoluble. And then generally your carbonates, your hydroxides, your oxides, they are insoluble, except if it falls under rule number 1, which is there are group 1 cations or ammonium cations. So for example, right, your sodium oxide. So this is a soluble salt. We just need to know that there's 3 methods of preparation for our salts, and we have to memorize these procedures. This is very important, right? And you need to know all the steps that are actually required for each method. Yes, you'll be expected to recite every single step, and this could be a 4 to 5 mark question in the exams, and we certainly do not want to waste any marks on them. So for our first method, it is precipitation. The general equation for a precipitation reaction is an aqueous plus aqueous reaction to give us solid salt. Again, you must have 2 aqueous compounds reacting together to give a solid salt, aka an insoluble salt at the end. So this means that this method is mainly for insoluble salts. Hint hint, that's why our solubility table is very important. So firstly, we want to add both compounds together. Both are aqueous reactants. Okay, this can be in a conical flask. And then we want to filter the mixture with a filter funnel. Okay, we do this because after this reaction, right, if you have a conical flask, for example, and you mix it both together, you are going to produce a lot of insoluble product. Okay, this is the insoluble product, right, which is the insoluble salt that you're trying to find. Then for our separation, we have learned, okay, in our separation techniques, that to take out a solid from a liquid, we need to do a filtration. So we're going to filter the mixture with filter funnel lined with filter paper, right? And when we do this, we pour this into our filter funnel, okay, lined with some filter paper, okay, and when we do that, right, our insoluble product is going to be called as the residue. Okay, the residue is what is on top of the filter paper, right? And whatever drips down here is considered the filtrate. This one we don't need anymore, right? Because we're mainly concerned about collecting the insoluble product, right? So afterwards, when we collect the precipitate as residue, we have to always wash the precipitate. Okay, so we wash the residue with distilled water to remove our soluble impurities. Okay, and then afterwards, we need to press dry the residue between pieces of filter paper. Why do we press dry? Because in general, right, when we're doing any kind of preparation of salts, right, we want to collect it in a solid form, and we want to collect it in a dry form, so it's just easier to keep as well. Our next method is the acid plus excess insoluble base or carbonate method. So what exactly is this method and why is the name so long? Okay, because the general reaction for this whole procedure is literally to react your acid with an excess insoluble base or carbonate, right? And this method is generally used to form soluble salts that are not in group 1 or they are ammonium salts. Okay, so in general, they are soluble salts that are not in group 1 or ammonium salts, right? The concept of this is that by adding excess insoluble base or carbonate, right, key thing is that all the acid would react, that's number 1, and the mixture will only have your soluble salt plus excess insoluble base or carbonate. We do this because in general it is easier to separate something that is insoluble, which is the excess insoluble base or carbonate, right? We can separate this out, okay, and we also make sure that all the acid reacts, because the acid is generally in an aqueous form. We don't want to leave it as a soluble impurity. You realize soluble impurities are very difficult to separate out. Okay, so we generally will filter to separate the soluble salt as the filtrate out. Okay, that's the first few steps what we're going to do. So first, we're going to pipette the acidic solution into a flask, and then we're going to add the insoluble base or carbonate with stirring. Okay, we're going to keep adding until the base or carbonate does not react anymore and remain soluble. Okay, insoluble. So this is the sign where all the acid has reacted. Alright, and how do I tell when we've added in excess? Right? How do we tell we've added enough? Well, in general, an example is if you react acid with a carbonate, right? As we learned in acids, bases, and salts chapter, right? Acids reacting with carbonates will give carbon dioxide. So when we've added in excess, right? When all the acid is reacted away, right? Then you're just adding carbonate. There's no more reaction. There'll be no more carbon dioxide. Okay, so we can use this as a gauge. Okay, for example, okay, for acid plus carbonate reactions, okay, you have no more effervescence of carbon dioxide gas, right? So this is a very telltale indicator, okay, as to whether all your acids reacted away. Another indicator is that your carbonate, right, still remains insoluble, right? So this is point number 2, right? Your carbonate remaining insoluble means it's not reacting anymore, and then you will just see all the residue, okay, in the solution. So you can imagine, right, in this step 2 over here, right, if I were to draw this out, your conical flask, okay, will be filled, okay, with a ton of residue over here, and this is the insoluble excess base / carbonate. And if all your acid has reacted away already, then what you should have left in your solution is just the soluble salt that you're trying to prepare, right? You should have no more acid, okay, after step 2. Then afterwards, you want to filter the mixture with a filter funnel lined with filter paper, right? So imagine you take that solution, okay, and you're going to filter it, right? So if we continue from step 3, okay, so step 3, right, we are going to filter, okay, with a filter paper, right? If we filter that mixture that we had just now, right, what will we have? We will have the insoluble carbonate or base, right, that will be caught in the filter paper. But again, we're not concerned with that, right? We're just separating it out. What we actually want is the filtrate. This filtrate over here, this is the soluble salt that we want. Okay, and we want to collect this filtrate over here. Okay, we don't really want the residue over here, right? So this is for step 3. So after that, we want to collect the salt, right, as the filtrate. And then what we want to do is we want to heat the solution to saturation, and then we cool for crystals to form. Okay, this is mainly part of the crystallization process, which we kind of went through in our separation techniques as well. So there's a lot of linkage to previous chapters, right? So afterwards, when we cool for crystals to form, right, we will then filter the crystals in the solution, right, with a filter funnel lined with filter paper. So you can imagine this is what happens in step 6. Okay, for step 6, okay, what we're going to do, okay, is we're going to filter again. Okay, so basically this soluble salt filtrate, right, after step 5, okay, you will still have some solution left inside, a saturated solution, but then you're going to get these like little crystals. Okay, these are crystals of our soluble salt. Okay, after step 5. Okay, and then we are going to filter it afterwards. So we can collect the crystals of our soluble salt, because again, we generally want to create and collect solids. Okay, so then you will have the crystals of our soluble salt as the residue, and then for our filtrate, you'll still have the solution of our soluble salt. There's still going to be solution inside. Okay, after we collect our crystals of our soluble salt, it's very important to go and wash the crystals. But keyword, we want to wash the crystals with little cold deionized water. Because if you use normal warm water or warm deionized water or normal temperature deionized water, you are going to wash, and then you're not going to look at it, and then afterwards, hey, what happened to the crystals? It's all gone because they are soluble salt. Remember, they're just going to dissolve in the water that you use to wash. So we use a little bit of water, okay? We lose a bit of product, but it's okay. Use a little cold deionized water. It's cold so that it doesn't dissolve as much as well, okay? And then after that, we want to press dry the crystals between pieces of filter paper. Alright, so I hope everyone understands the whole procedure when it comes to reacting an acid plus an excess insoluble base or carbonate to get a soluble salt that is not with a group 1 cation or ammonium cation. Okay, our last method is the titration method. So our titration method is used to form a group 1 or ammonium salt, right? And the concept for this, right, is that if you are forming a group 1 or ammonium salt, right, these are soluble salts as well, right? The cation is going to be from group 1 or ammonium cation. So for example, Na plus, K plus, or ammonium cation, right? Because the cation is these few, right, you cannot use the excess insoluble carbonate or base method. Okay, because you don't have an insoluble base or carbonate with the group 1 cation or ammonium cation. So because of this, you need to use another method. You need to use an exactly measured method, okay, to ensure the produced salt, right, has no excess reactants or impurities. Okay, and we will use titration for this method because you will have an exact reaction from this. Okay, and in general, these are acid plus alkali reactions. Right, you don't really want to use any other kind of reactions for this case. So first we want to pipette acidic solution into the flask, and then we want to pour alkaline solution into a burette. So what you're going to have, okay, is a conical flask. Okay, for example, it's an acidic solution. Okay, and then you have a burette over here. I'm going to try my best to draw the best burette I can. Okay, with a little tap over here. Okay, and you're basically going to fill this up all the way with alkaline solution. Okay, so this is the general setup for your titration, and you will most likely be able to practice this in the lab as well. Right? After that, you want to add methyl orange indicator into the flask. Right? So this is, we'll turn it orange. Right? So it's a methyl orange indicator. Okay, the purpose of this is that this is a pH indicator. At the moment when there is an exact neutralization, so an exact reaction between the alkaline and the acidic solution, right? Okay, this is the point where you will see a color change in the pH indicator, and then you can stop the reaction. Okay, you will stop the burette from pouring any more solution down. Alright, so remember this indicator, right, can be easily swapped out. Right? You don't need to use methyl orange indicator, you can use another indicator like phenolphthalein, right? Or thymol blue, right? So depending on the question itself. But in general, I like to use methyl orange. It's just a very easy pH indicator to use. And then you will titrate the acidic solution with the alkaline solution. So you will let the tap loose, okay? And then you will just do the reaction, right? And you keep swirling the conical flask as well. That's part of a good titration procedure, right? And then you will do it until your methyl orange indicator, right, will change from the neutral, actually not orange, it's actually from the acidic colors, from red, okay, to yellow, right? where it will turn from the acidic color because it was an acidic solution at first, but as you keep on adding alkali, okay, it will be less and less acidic until it turns into the alkali color. That means you added a bit more of excess alkali. Okay, then you should stop it and then you record the burette reading. Okay, so this would be when you record the burette reading, you are recording the exact volume of alkali you used from the burette. Okay, so once you noted that down, right, you will definitely be using this later on. Also notice how in my procedure over here, I mentioned the exact color change of the indicator, and do realize that this is the point of full neutralization. Okay, and don't forget that this is just to get the exact measurement of alkali. Okay, we cannot use the product of this solution. Yes, we have our soluble salt, but remember we added pH indicator. This is an impurity and we don't want that. Okay, and we don't have a way to separate out the pH indicator afterwards. So the easiest way is to just repeat the titration, but without the pH indicator. Okay, this is why we recorded the burette reading from just now. So what we're going to do is we're going to repeat this so it just doesn't get contaminated with the indicator. So you see in step 5 over here, we're repeating that titration, right, but without the indicator, and I specify we're going to use the same volumes of acid and alkali that were used in the original titration. Once we've done that, you realize that all we have left is a conical flask, alright, with the soluble salt. Okay, the soluble salt that is group 1 salt, or ammonium salt. When we have this, right, then we can just do our crystallization procedure. So we will heat the solution to saturation, we will cool for crystals to form, right, and then we will filter the crystals in the solution with filter paper, and then you will collect the salt crystals as the residue. And then don't forget, just like just now, when we have the crystals, we still have to wash the crystals with little cold deionized water, and then we press dry the crystals between pieces of filter paper. And that is how we get our dry solid crystals of our soluble group 1 ammonium salt. Okay, so do realize over here that the steps 6 to 10 are very similar with the previous method. Okay, and this is because this is just the general crystallization procedure that you have to do, right? So I just put this here in case you're going to memorize it twice. I'm telling you it's very similar, so you don't have to memorize it twice. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.